Hello and welcome to this third of 4 films about stage 3 calculations. This is all about percentage purity, as you can see there. If you can do mole calculations that you've been doing up until now, then you can do these, okay? Or the only difficult thing about these is that they involve a few more steps. So when we do this practice calculation involving percentage purity, we're going to see if we can start drawing diagrams to show what's going on in an attempt to kind of visualize the process so that we can see that even though there's a few steps going on, each individual step is actually quite simple. And if we can put them together, then we'll get the answer. This first example is quite a simple one. In the fourth film, we'll go into a slightly more complicated example. You might think by the end of this one, well, what was the point of drawing a diagram for that one? But the next one, hopefully, it will be a bit more obvious. You're under no obligation to draw a diagram in an exam, but if you do struggle with these questions, then it might be a good idea. Here is the example that we're going to do, okay? And it says, when dilute hydrochloric acid is added to 5.73 grams of contaminated calcium carbonate, okay, so I have got not 5.73 grams of calcium carbonate, but 5.73 grams of something in which there is calcium carbonate. Okay. Now it could very well be that the calcium carbonate's in the majority and not the minority. It doesn't really matter. I've just kind of represented it as a slice of a pie. Okay. We don't know what percentage is calcium carbonate, but we do know, surely, that the percentage is going to be the mass of the pure over the total mass. Okay. So if we can find the mass of calcium carbonate, we know the percentage purity. Okay? How do we find the mass of a substance? Well, the mass of a substance is N times big M. Okay? Do I know what the number of moles of calcium carbonate is? Well, no, not at the moment. But the number of moles of calcium carbonate surely is related to this other substance that we're told about. Okay? 2.49 grams of carbon dioxide, there it is, or carbon dioxide. Okay, so it's related to the number of moles of carbon dioxide. Is that statement true? Is the number of moles of calcium carbonate, which is 1, the same as the number of moles of carbon dioxide? Well, yes, it is actually true. Okay, so as soon as I've found the number of moles of carbon dioxide, I'll be able to go ahead and find this, and then I know that, and then I know that, and then I know the percentage. Anyway, so let's go ahead and do that. Okay, the number of moles of carbon dioxide, obviously, oops, CO2. Obviously, by now you could do that if you were given some PV equals nRT type data, but we're given a slightly simpler case, which is the mass over the molar mass, which in this case is 2.49 grams over 44.01 for carbon dioxide. And what does that equal? That equals 0.0566. 0.0566 moles. Okay. So the number of moles of carbon dioxide is that, therefore the number of moles of calcium carbonate is also that. And we can go ahead and find the mass of calcium carbonate by saying it is the number of moles times the molar mass, so that's 0.0566 multiplied by 100.09. And what does that equal? That equals 5.66 grams. Not surprisingly, it's quite close to that. Okay, so 5.66 grams of this 5.73 is calcium carbonate. So let's go ahead and find the percentage purity. Okay, 5.66. If you can't do this, I'm quite worried about your maths. I'm sure you all can. It's that times 100%. Put it into your calculator, and what do you get? You get 98.8%. As with all calculations, I'm doing things to 3 significant figures here because that's all you need to do in an exam. Don't bother writing out millions and millions of significant figures in your calculations. There's no point. Okay, I think that's the only example in this one. Yes, it is. So the next film will deal with a slightly more difficult example of that. It will just have a few more steps. Hope you like my picture in that one. Yeah, get some practice done.